Let's see, one more. Okay. All right, gentlemen. Hopefully Lenny and Randall will be here shortly. But anyways, I got a video to share this morning on pole topping safety. This was a accident that happened a few years back, but pretty good video. We watched it a few times throughout the semesters, and it's pretty good. So, and pole topping is something that you'll do going to work for utility when you're changing out poles, bringing the old poles down, setting a new pole in line, and it's a pretty good video. So I'm gonna go ahead and share my screen.
Okay, and while he's getting ready to share his screen, Mr. Lee Martin and Mr. Ryan Embry are here today. The rest of you are not.
Bam.
Need to see you.
Jordan's here.
No, you're not.
That was good.
I don't see you.
There you go. There you go.
I don't look too pretty.
Luke's
I'll show my face for a little bit.
Oh, wow.
God, you look glorious. Spencer, Khalil's here. Lucas McDowell's in the dark. Khalil, Lee Martin. There you go. Good. Ross has got his wife beater on. Mm-hmm.
All right.
I see a black share screen. There you go. I got it.
You see it?
Got it.
All right, guys. Can y'all hear that?
Yes.
Yeah.
Day, one that had followed several other days just like it. On Tuesday, September 16th, 1997, the Weather Service reported a full inch of rain had fallen during a 24-hour period. The accident occurred at approximately 3 o'clock in the afternoon. Jerry Cade and his crewmates began topping the 5th pole, their last job of the day. Jerry and a crewmate were working up in the bucket truck. The top of the pole was tied off with a line and secured to a tree nearby. A third ground crew member put tension on the line to pull the top of the pole away from the crew in the bucket truck toward the tree. Jerry was operating the chainsaw and he made the cut. There is some uncertainty about how the accident happened. The pole falling wrong may have been due to the weight of the insulators or the cut used, causing the pole to twist toward the boom.
The 20-foot piece of pole fell toward the bucket, breaking the boom and throwing Jerry, who was not tied in, out of the bucket. He fell 20 feet to the deck of the truck below. His partner managed to stay in the bucket without getting hurt, but Jerry did not survive the fall. Due to massive head injuries, Jerry was gone before medical personnel arrived. Unfortunately, there are no official safety codes when it comes to pole topping. After looking into the cause of Jerry's death, Aztec Electric and the Department of Labor and Industries felt it was important to make this video to demonstrate safe pole topping methods and show it to everyone from the experienced veteran to the first day employee on the job. I'd like to run through the safety checklist every employee on a pole topping job site should know. Before a crew ever starts a pole topping job, it's important to complete the following checklist. The purpose of forming an initial safety plan is to review each job site for ground and weather conditions, locate any potential hazards, locate all electrical lines and sources in the immediate area, establish safe truck positioning, inform all employees of job site conditions, the types of pole cuts and how they are used, and answer any questions employees have regarding safety policies and procedures. This information is gathered and discussed at the first tailgate safety meeting. It's important to always review and double check the clearance requirements anytime a crew is working on or near energized lines. Contact the owner or serving utility of the line to obtain clearance necessary to perform the job. Document the time and person giving your crew clearance after it has been obtained and make sure all grounds and shorts are applied. Every job is different. The foreman and crew must conduct a meeting to review the work to be done at the start of the day's work and anytime working conditions change during the day. The tailgate team meeting should include review of the job site specific safety manual, safe working conditions as outlined in the Washington Administrative Code, determine what safety equipment will be used, decide which lines will be guarded with what types of barriers, discuss type of cut to be used, a wedge cut is the safest, decide on the safest procedures for removal of the pole tops, and discuss job site emergency procedures. Just as important as job pre-planning is having the right type of equipment on a pole topping site and knowing how to use it. General personal protection equipment must be worn at all times. The following is designed for your own personal protection, as well as the protection of your fellow workers. Hard hats to protect you from overhead hazards. Safety glasses to protect your eyes from flying debris. Gloves to protect your hands from cuts and other hazards. Earplugs or muffs to protect your ears from loud sound levels. Full body harness designed to distribute the force of a fall over your full body. Lanyard attaches a full body harness to an anchorage point in case of a fall. Flexible ballistic nylon pads or shafts to protect your legs when necessary. Lineman's rubber gloves, test certified with keepers, used as personal protection barriers against electrical shock up to 5,000 volts. Rubber blankets, test certified, heavy rubber blankets to protect you against accidental contact and electrical shock when working on or near an electrical line. Spiral line sleeves, fiberglass cylinder-shaped barriers placed over and around energized or potentially energized lines. Grounding equipment, backup conducting connection equipment used in place of the earth. Other types of general equipment used on a pole topping job are aerial man lift or bucket truck, designed to elevate you to the work area on a pole. Line truck or digger derrick, used to secure the pole and remove the piece when the pole is cut. Hand line, a rope and pulley assembly used to raise and lower material and equipment. Rope slings, heavy braided rope or line used for rigging and securing the equipment to the pole for removal. Chainsaw, after the pole topping method has been determined, used to cut off the top of the pole in one piece or in several chunks. There are two recognized methods of removing the top of the pole. The first is called chunking. That's when the top of the pole is removed in several sections, such as these. For safety reasons, chunking is a preferred method. This allows the lineman easier control of the smaller pieces. This may take longer, but it's well worth the extra effort. After the bucket truck is positioned safely and the outriggers are on level, stable ground, all hardware and attachments are removed and lowered down on the hand line or with the boom and the line of the truck to reduce the weight on the pole. A piece or chunk is cut off the pole in a small enough section that an employee can remove it and lower it down with the hand line. This process continues until the pole is cut down to the desired height. An alternate method to chunking is the single section method. This refers to the removing of the top of the pole in one large piece. The bucket and line truck are stabilized at safe distances from each other with the pole easily accessible from either truck. The boom of the line truck is placed near the top of the pole where the single section will be removed. The two employees in the bucket take a sling up and attach it near the top of the pole utilizing a choker attachment. The sling is attached to the winch on the boom of the line truck. The ground operator takes up the slack on the winch line in order to place a small amount of tension on the line away from the employees in the bucket. The employees in the bucket truck then make one safe and proper cut. The ground operator then utilizes the line truck to move the single section of the pole away from the employees in the bucket and lowers the single section of the pole to the ground. After the top of the pole is removed, the crew spends the time to clean up the area of all the debris. The acting utility and owner are notified immediately that we are clear of the lines and leaving the project. This video is dedicated to Jerry Cade. Our hope is that the safety information provided here will help prevent this type of accident from happening again.
Jerry was a conscientious employee, a journeyman lineman with over 20 years of experience. But nothing we do now can bring Jerry back. What we can do, however, is remind ourselves that safety first is not just a catchy phrase we teach our children. Good safety practices reduce the risks we face every day in our jobs. There's an old saying, expect the best, but prepare for the worst. Maybe the crew was in a hurry to get that fifth pole procedure over with. Maybe not, but the crew surely never thought something like that would happen to them. Well, it did happen. And what we can do is honor Jerry by learning from this tragedy. For Jerry, we should never let this happen again.
When it comes to safety, it's important to plan your work, then work your plan. Attempting to shortcut a job may get the job done faster, but is it worth the risk to yourself or your crewmates? None of us can avoid risk in our line of work, but we can do our level best to prevent the chances of accidents occurring. An ounce of prevention is worth its measure when lives are at stake.
Good video, real life lesson there, guys. I mean, it does not pay to take shortcuts, especially when you're doing that kind of work. You're, within a hot conductors like that, trying to, cut the top of a pole out, or you're taking shortcuts because you didn't feel like putting on the harness or whatever, like that Jerry guy did. I mean, he might have been okay if he had a harness on, if he'd have been, attached in the bucket, but he didn't, and suffered a severe, a very critical injury, head injury, and he didn't make it. So there's very good points in this video about things that he did wrong, such as the main thing was, I think, was not having his safety. Either he had it on or he didn't have it connected in the bucket. So that was one of the very detrimental things that happened to him. Also, he might have cut a too big, what do you say, 20-foot section of that pole he cut out.
20-foot section there, and I don't know if they stripped the pole off before they did it. So
right, and it had those big insulators on it. So it was heavy enough where it broke the boom and threw him out, and pretty much, I guess, it crushed his head. But guys, you want to make sure that you're doing everything you can safely. Follow your company rules where you go with. I know when we did pole chunking at Duke, it had to be documented in our pre-job brief that we were either gonna let it down on the hand line like they did, or cut it, put the piece in the bucket with us, let the bucket down, and then throw it at the bucket when the bucket got closer to the ground. So whatever your company's safety rules are, follow them to the letter, because there's no sense in you getting hurt or anybody else getting hurt. I mean, and that's where a lot of these safety rules come from, is because somebody did something wrong and it caused a serious injury or a death. And that's where these rules come from. So, Professor Shoemaker?
I mean, I'd actually like to go through this again and get student interaction as far as all the safety things. And I understand this is kind of old.
Yeah.
What would you say? This is mid 80s in here somewhere?
Something like the 90s, 80s, late 80s, 90s, somewhere along in there.
Yeah, let's go ahead and start it from the beginning and talk about a couple of things here. So go ahead, right there. I'll ask you to pause it.
Okay.
It was a cold, rainy day, one that had followed several other days just like it. On Tuesday, September 16th, 1997, the Weather Service reported a full inch of rain had fallen during a 24-hour period.
That's probably the El Nino storm.
It was what?
The El Nino storm back in '97.
Okay.
Approximately 3 o'clock in the afternoon.
Go ahead and pause it there.
Cade and his
So conditions are bad, weather is bad, ground conditions are bad. What time is it?
Getting late.
3 o'clock. Yes, 3 o'clock in the afternoon, guys. So I would highly suspect, there's a little bit of, I would say laziness, a little bit of, what do you call it? Fatigue, yeah, sitting in there and a bit tired from the day's work. They've probably been working through bad weather. And I would highly suspect, hey, let's get this one done. We've done it 100 times before. Probably some shortcuts going on.
Correct.
Go ahead.
His crewmates began topping the 5th pole, their last job of the
Pause
day.
it there.
Jerry and a crewmate were working up.
Okay. You see those insulators that they have right there? You're looking, if I'm looking correctly about the size of the guy compared to it, that's a couple 100 pounds per insulator.
Yeah.
So the thing that you're going to need to do, and do this in all cases as far as pole chunking, and we get down to the end, I'll let you know why we do pole chunking. We did full sections. We went down to the bottom, we sawed it, and we pulled out full sections, and we even quit that. We went to full pole chunking. We never cut sections out. Is to strip all the material, and especially the pole ground, off the pole before you start cutting it. Take all the weight off that you can, and the pole ground that goes up to the top of the pole, because it's a conductor and you don't want to saw through it, off the pole before you start chunking it out. Go ahead.
Up in the bucket truck. The top of the pole was tied off with a line and secured to a tree nearby. A third ground crew member put tension on the line to pull the top of the pole away from the crew in the bucket truck.
Okay, pause
toward
it.
the tree.
Guys, when you're working with heavy weights there, don't wrap the rope around your glove. All right, just hold it with 2 hands and let it free. Once you wrap around your glove like that and you've got really hard tension or weight on it, it's going to pull that glove off and it's going to injure your hand. Don't wrap ropes around yourself. Go ahead.
Tree. Jerry was operating the chainsaw and he made the cut. There is some uncertainty about how the accident happened. The pole falling wrong may have been due to the weight of the insulators or the cut used, causing the pole to twist toward the boom.
The 20-foot piece of pole fell toward the bucket, breaking the boom and throwing Jerry, who was not tied in, out of the bucket.
Pause it.
He fell 20.
Guys, 20 feet of pole is a lot of pole. That's you see our 30-foot poles that we have out there, and how much is in the dirt? 6 feet, right? 10%? No, 5 feet's in the dirt. So what you see above ground is about the size of the pole section that they're cutting out. That's huge. That's way too big of a cut to be making and trying to maneuver down there with a guy and a piece of rope. Jerry got thrown out of the bucket, right?
Yep.
Was he wearing a safety harness?
No.
No.
Where does a safety harness and lanyard attach? Does it attach to the bucket or does it attach to the boom?
The boom.
The
Oh.
boom, correct.
Oh.
All right, yep, there are boom attachments that some trucks come with. And if not, you can actually put a boom strap on that ratchets down and you attach to the boom strap. All right, you never attach to the bucket itself. The bucket, and I don't want to make this sound scary, the bucket attachment to the boom is the weakest part. Okay, and there are weight limits to it. If anything's going to break off, it's going to be the bucket, especially if it has crashing weight on it like that. So you attach to the boom. Now, are you going to get slung around and probably injured? Yeah, more than likely in an event like this, but you're not going to fall to the deck of the truck. Go ahead, Professor B.
Feet to the deck of the truck below. His partner managed to stay in the bucket without getting hurt, but Jerry did not survive the fall. Due to massive head injuries, Jerry was gone before medical personnel arrived. Unfortunately, there are no official safety codes when it comes to pole topping. After looking into the cause of Jerry's death, Aztec Electric and the Department of Labor and Industries felt it was important to make this video to demonstrate safe pole topping methods and show it to everyone from the experienced veteran to the first day employee on the job. I'd like to run through the safety checklist every employee on a pole topping job site should know. Before a crew ever starts a pole topping job, it's important to complete the following checklist. The purpose of forming an initial safety plan is to review each job site for ground and weather conditions, locate any potential hazards, locate all electrical lines and sources in the immediate area, establish safe truck positioning, inform all employees of job site conditions, the types of pole cuts and how they're used, and answer any questions employees have regarding safety policies and.
Okay, so really, this is what, it's not what we call an ANSI, American National Safety Institute, or an OSHA rule. There is, like you said before, there is no written rule out there as far as something official that's going to tell you how to properly do pole chunking. But every company's safety manual should have it in it. We have it in ours. So this is what they're talking about. By the way, this is what they're talking about when they're looking in their safety manual. So follow that to a T. Go ahead, Professor V.
Okay. Let me get my mouse back over there.
Procedures. This information is gathered and discussed at the first tailgate safety meeting. It's important to always review and double check the clearance requirements anytime a crew is working on or near energized lines. Contact the owner or serving utility of the line to obtain clearance necessary to perform the job.
Guys, do you know what a line clearance is?
Probably clearance from whatever utility you're working with to shut the power off and coordinate when they're shutting it off and all that.
Right, you're right on it. It's pretty much, yeah, you're gonna de-energize the circuit. And I can, Professor V, I can chime in on this also. You're not gonna get a line clearance to chunk a pole out,
Mm-mm.
not anymore. All right, that's way too much work, one, and two, getting a line clearance means you're gonna have customers without power. Now, are you gonna get permits on the line to do your work? Yes. But actually de-energizing the line to be able to chunk a pole out, which should take you, no more than an hour. No, you're not going to get a line clearance these days because of the amount of work that's involved, one. And two is your disruption of customers. So you're going to have to take more time to do it energized than you would if you had a line clearance. Go ahead.
Job. Document the time and person giving your crew clearance after it has been obtained, and make sure all grounds and shorts are applied. Every job is different. The foreman and crew must conduct a meeting to review the work to be done at the start of the day's work and anytime working conditions change during the day.
So pause it.
The tailgate.
So you've got a written rule for pole chunking and pulling poles out and doing whatnot in a manual. Then you have to have a what every day?
Safety brief.
Yeah, a safety brief, tailgate meeting. This should be 5 to 10 minutes. Everybody's involved. I will let you guys know that even starting out at a new company, you might be the guy that has to give the safety brief.
Yep.
They want everybody involved, the first day guy to the guy that's been there for 30 years. Don't freak out and think you have to know every single little detail that's going on about safety on the job site. It's more of a learning process for you. That if you're out there, well, the lines are energized, we're gonna need rubber hoses. Our procedure is to chunk a pole, and that's all I can remember. Well, those are great points. And if anything else comes up in the group that you're doing the tailgate meeting with, that's gonna be drawn out also. So don't, know what you know and tell what you know. Go ahead.
Tailgate team meeting should include review of the job site specific safety manual, safe working conditions as outlined in the Washington Administrative Code, determine what safety equipment will be used, decide which lines will be guarded with what types of barriers, discuss type of cut to be used, a wedge cut is the safest, decide on the safest procedures for removal of the pole tops, and discuss job site emergency procedures.
Okay, stop.
This is important.
If you could just get a couple frames back there. That's good. Types of cuts to be used, Professor V. First, does the class know what's a wedge cut?
That's where you cut out a wedge, and whichever direction you're trying to drop it, you cut the wedge on.
Right, cut a wedge in it on one side, go to the other side, cut it, and it should drop the way of the wedge, right?
Right.
All right, correct. Is that the
Yeah.
same that you used to do?
No, we didn't wedge cut. We kind of cut it on one side and then either below it or above it on the other side, cut through the other side and then snapped it off.
Okay, we're gonna see a video on that in just a moment too. To me, as far as controlling the section of pole that you're trying to cut out, that is the best way to do it.
Right.
And we'll show you that here in just a moment. Okay, go ahead.
Procedures for removal of the pole tops, discuss job site emergency procedures. Just as important as job pre-planning is having the right type of equipment on a pole topping site and knowing how to use it. General personal protection equipment must be worn at all times. The following is designed for your own personal protection as well as the protection of your fellow workers. Hard hats to protect you from overhead hazards. Safety glasses to protect your eyes from
Go back to the safety glasses one
This?
with the first guy. No, the first guy. I love tearing videos up. All right, right there.
workers. Hard hats to
There you go.
protect you from
Take a look at those glasses.
Definitely not safety glasses.
How can you tell?
They're supposed to like be able to cover like the side of your eye as well.
That helps out. What else?
They're not made of metal.
They are made of metal. Yeah. Metal glasses, metal of any kind in a glass is not a safety glass. Okay. No metallic glasses are allowed. If there's anybody out there that wears a prescription, the company that you're working for will pay for the safety glasses part You just have to pay for the prescription part. So you can get prescription safety glasses with a share in costs with the company that you're working for. Those
Correct.
are not safety glasses. How about what's he wearing?
A watch.
Or a watch or something.
Well, yep, he's got a watch on. What
I
else?
don't.
What's that big white thing on him?
Oh, he's not wearing his fire retardant.
shirt.
Yeah, I would assume, I'm hoping this is probably cotton, which is good, but it's not a fire retardant uniform. If you're on a job site, on the ground or in the air, the whole crew must wear fire retardant uniforms. Go ahead.
Overhead hazards. Safety glasses to protect your eyes from
Oh.
flying debris.
I can pretty much guarantee you that homeboy here is wearing a polyester scarf with those pretty balloons on it. Huh?
Hey,
Would you agree?
Yes.
Yeah, that's probably polyester, gentlemen, especially back in 1997 when, Devo and the flock of seagulls were all going on here. Okay? You can't wear anything polyester. That thing's just going to melt right into your neck. Go ahead.
Gloves to protect your hands from cuts and other hazards. Earplugs or muffs to protect your ears from loud sound levels. Full body harness designed to distribute the force of a fall over your full body. Lanyard attaches a full body harness to an anchorage point in case of a fall.
You can pause it.
Flexible ballistic.
Pause it on the lanyard part, and I might just show another picture of this. Go a little bit more forward.
Designed to distribute the force of a fall over your full body. Lanyard attaches a full.
Now, okay, perfect right there. All right, full body harness. I mean, that's pretty much standard to the industry, and you've seen me wear the full body harness that we wear in our bucket truck. Now, you can make a lanyard out of anything. You can take a sling or a strap or whatever and make a lanyard out of it. I would highly recommend that if your company just gives you a straight strap lanyard, that you go out and buy what they call a shock absorbing lanyard. And try to encourage the company to use a shock absorbing lanyard. Why do you want to use a shock absorbing lanyard?
so you don't get your bell rung when you hit the end of the rope.
Right. So when it's not your bell, it's Tom and Jerry. Okay.
Yeah.
That's how you're going to fall. Typically, a 200-pound man that's going to fall in a non-shock absorbing lanyard, the shock to the groin area right there is going to be between 3,000 and 5,000 pounds from the shock and the fall. A shock absorbing lanyard can take that down, and I think the minimum requirement now is 900. So you're doing a lot of help to yourself, if you want to put it that way, if you use a shock absorbing lanyard, not just a straight lanyard. Okay, go ahead.
Full body harness to an anchorage point in case of a fall. Flexible ballistic nylon pads or shaps to protect your legs when.
Was that a
Yeah,
question?
I'm in the garage in my class.
What you say?
No, I think he was just talking with somebody, but it's a good place to stop this. Chaps are required when you're on the ground doing chainsawing.
Right.
Okay, if you're in a bucket or
Right.
climbing a pole and using a chainsaw off a pole, chaps are not required. But now, and golly, we didn't implement this probably maybe about 10 or 15 years ago is when we started implementing ground chaps.
Yeah.
So, yeah, and they work, I have
Yeah.
to admit. Go ahead.
Necessary. Lineman's rubber gloves, test certified with keepers, used as personal protection barriers against electrical shock up to 5,000 volts.
Pause it.
Rubber blanket.
All right, how much did he say in his voltage right there?
500,000.
5,000 volts. I don't know where you're going to get 5,000 volts on a primary line.
Mhm.
That's extremely low. Now, this is not going to be a trick question. Think about it. And I want you also put in your heads right here. We talked about phase to ground voltages and phase to phase voltages. What kind of rubber glove are you going to use? Voltage wise. So I'm working on a line that's 7,200 volts phase to ground. And two phases together is 12,470. What voltage glove am I going to use?
With a 25 kVA.
20 kV, 20 to 25 kV. Okay. Know the system that you're working on, guys. That's one of the reasons why we teach voltages in that manner, phase to ground and phase to phase. You're going to have to use a voltage glove that meets those requirements. Okay. 5,000, Robbie?
Yeah.
I mean, even at 2,400 volts, which is the lowest primary voltage, that is what, 4,160
Yeah.
phase to phase. 5,000, that's a small margin.
Yep.
Right there on the rubber glove side. Okay. Rubber blankets and rubber gloves, when we get to the hardcover, pause it there, Professor D.
It's test certified heavy rubber blankets to protect you against accidental contact and electrical shock when working on or near an electrical line. Spiral line sleeves.
Okay. So they do make these and they're used regularly right here. You'll notice, does he have to put them on with his hands? What's he using to put them on?
Yeah, you'd have to put them on his hands.
Shotgun.
Yeah, he's using a shotgun, and this is what we call hardcover. What do you call it, Rob?
Oh, that's what that is?
That's hardcover.
Yeah, we call this hardcover. It's more of a rigid fiberglass type product that you actually just spiral onto the line. You can see that spiral in the middle. So you never have to make physical contact with rubber gloves to the line. So that's probably a voltage above the rating of his rubber gloves.
Mm-hmm.
And you're able to put them on using the stick. Now you got stick insulation plus the insulation of the hardcover that you're putting on the line.
Okay.
Fiberglass cylinder-shaped barriers placed over and around energized or potentially energized lines. Grounding equipment. Backup conducting connection equipment used in place of the earth. Other types of general equipment used on a pole topping job are aerial man lift or bucket truck, designed to elevate you to the work area on a pole. Line truck or digger derrick, used to secure the pole and remove the piece when the pole is cut. Hand line, a rope and pulley assembly used to
A
raise
long hand line.
material and equipment.
Say it again.
It's a long hand line.
It is a long hand line for them short
Rope
poles.
slings, heavy braided rope or line used for rigging and securing the equipment to the pole for removal.
Okay, stop, pause it there. And just go back to the sling part.
Cut. Hand line, a rope and pulley assembly used to raise and lower material and equipment. Rope slings.
Okay, somehow we got out of the rubber glove use, and I guess that's because we went beyond line grounding. We used to use back in the day what they called a wire sling or a wire rope sling.
That's right.
We discontinued use of those. Why?
A wire in it.
Well, yeah, one, it's a conductor, right? And if you get that thing anywhere close to an electrical line, that's not good. What else? They're notorious for fraying,
Right.
right? And they'll fray at the connection points of where they've been crimped at. They'll poke through your leather glove, and sometimes they'll poke through your rubber glove, and you'll never know it because it never reaches your finger. So don't use steel slings. You can always use some kind of nylon product as far as your sling is concerned. Now, what method is he using? Is he using the chunky method or a whole section?
I would guess a whole section.
He's going a whole section. Now, I want you guys to think back, and I want somebody else other than Ryan Embry to answer. Where do we catch a pole when we set it in the ground? Below balance, at balance, or above balance? Who was that? All right, I'll pose that question again. Wake you guys up.
Above
Set
balance.
a pole in the ground. Do we catch it below balance, at balance, or above balance?
Above balance because you need the heavy side. Yeah, above balance so we can work with the heavy side, right?
Exactly. So you're able to, the heavy side stays where? Down.
Yeah.
Got it.
If
More
you catch a
control.
pole, if you catch this pole and you get ready to pull it out in one section and you catch it below balance, well, where's it gonna go once it's cut?
It's
Gonna be chopping.
It's gonna do a complete flip. It's gonna do a complete flip, and 99% of the time, it's gonna completely flip right on top of you.
Yeah.
So if your company is using this method, which I don't like, make sure that you're catching it above balance. All right, even if you have to go, 5 or 6 feet from the top and 14 feet below, make sure that you catch it above balance. Go ahead, Professor B.
Heavy braided rope or line used for rigging and securing the equipment to the pole for removal. Chainsaw, after the pole topping method has been determined, used to cut off the top of the pole in one piece or in several chunks. There are two recognized methods of removing the top of a pole. The first is called chunking. That's when the top of the pole is removed in several sections, such as these. For safety reasons, chunking is a preferred method. This allows the lineman easier control of the smaller pieces. This may take longer, but it's well worth the extra effort. After the bucket truck is positioned safely and the outriggers are on level, stable ground, all hardware and attachments are removed and lowered down on the hand line or with the boom and the line of the truck to reduce the weight on the pole.
All hardware. All
Say it again.
hardware.
All hardware.
And strip the pole ground down. All of our poles have pole grounds on them,
Yeah.
bottom to top. So strip that pole ground down also. Now he's using the wedge method right here. I don't kind of get this. Why is the rope underneath it?
That's what I was just thinking.
I don't get it. Unless he's using that to hang his hand line. Okay, and he's using the truck above. I don't know.
Well,
Guys, go ahead, Professor B.
what we used to use this for, they call it a drop crotch cut. You can see it tied up here, and it's actually runs down behind it a little bit, and then you tie it here, and when you cut it, it kind of falls into itself.
Okay. Yeah,
Yeah.
that's a tree trimmer method.
Yeah.
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 Okay, guys, in the chunking part of it, which it looks like he's getting ready to do right here, how much you gonna chunk?
5 feet.
No.
All right, let's see. Is Luke Simmons in here?
Probably only about 2 or 3.
I think Luke's in here somewhere, I guess. I don't know.
I'm right here.
Okay, how much? Hey, let's say 3 feet weighs about 75 pounds. How much you gonna chunk?
Probably about 2 feet then.
Yeah. Chunk what you can handle. All right. Now I'm going to show a video after this one of a guy that's 6'5", weighs about 260, and he's a hoss. Now he could probably take on 100 pounds, maybe a little bit more, with minimal effort. Chunk what you can handle. There are some places where I've been, as far as the bucket configuration and lines I'm working around, that I've chunked 2 feet at a time.
Yep.
Yeah, just small pieces. I throw them in the bucket with me or lower them down. Chunk what you can handle. And don't be a hero. Go ahead.
The pole in a small enough section that an employee can remove it and lower it down with the
Now,
hand.
that's a pretty healthy chunk.
The process continues until the pole is cut down to the desired height. An alternate method to chunking is the single section method. This refers to the removing of the top of the pole in one large piece. The bucket and line truck are stabilized at safe distances from each other with the pole easily accessible from either truck. The boom of the line truck is placed near the top of the pole where the single section will be removed. The 2 employees in the bucket take a sling up and attach it near the top of the pole utilizing a choker attachment.
Above balance.
The sling is attached to the winch on the boom of the line truck. The ground operator takes up the slack on the winch line in order to place a small amount of tension on the line away from the employees in the bucket. The employees in the bucket truck then make one safe and proper cut. The ground operator then utilizes the line truck to move the single section of the pole away from the employees in the bucket and lowers the single section of the pole to the ground. After the top of the pole is removed, the crew spends the time to clean up the area of all the debris. The acting utility and owner are notified immediately that we are clear of the lines and leaving the project. This video is dedicated to Gary Cade.
Okay. So you see, in me and you guys discussing about the video here, there's a lot of other stuff that's going on that's involved in this thing. The
Yeah.
biggest part is right here, don't bite off more than you can chew. Okay. You got questions about, and this, I mean, Robbie, how many times have you done this?
Jeez, lots.
Yeah,
Hundreds.
this goes on very regularly. Why do we do it in the first place?
Yeah.
Anybody got that idea?
Remove a damaged pole.
That's a good reason why. Anybody else? So when you go
You
to
have to change the direction of lines.
that works. When you go to change out a pole, who's attached to it?
The customer.
You've got electric. What else?
Oh, telephone.
Yeah, if you've got a pole that you need to change out and you've got telephone and TV cable, and it's more work involved in doing that than you're prepared to do, especially if you have underground wires coming off that telephone and TV cable, you're gonna have to chunk that pole off all the way down to their connection point.
Mhm.
And that's a pretty good distance right there. So what you'll do is you set your new pole right beside the one that you're changing out, transfer everything you have electrically to the new pole, chunk it out down to the telephone, and in some cases, tie off the old pole to the new pole until they transfer over to your pole. But that pole that you had sticking out of the top above them still has to be chunked out. Okay, that's the most common that you're going to see out there as far as pole chunking in those situations. And I can guarantee you, pole change outs are regular.
All the time.
Yeah. How long is a pole expected to last? Any guesses?
50, 60 years.
10 years.
5 years.
Bust
Years.
that, there you guys, I appreciate the guesses. 50 to 60, bust that in half.
Damn.
You're expecting
30.
to get 30 to 35 years out of a pole. Now, if some poles been out there since the 1920s, yeah. Some last forever, and it's just the treatment that they've gone through. But they
Right.
expect to get 30 to 35 years out of a pole. And there are hundreds of thousands of poles in one single utility.
Yep.
So that's a constant thing that's going on out there in the world. Plus, I think somebody had brought it up before. If you've ever driven through North Myrtle Beach, where are the poles set at as far as the highway is concerned?
Same it.
You drive through North Myrtle Beach, both sides of the road right there, and that's, I think, 45, 50 miles an hour through there. Those poles are set right behind the curb. You're going to get poles that are going to be hit all the time by cars. So that's another situation. Okay. Any questions? That was a lot on discussion, and we're actually going to go through a little bit more on it before we get into the meat and potatoes of three-phase transformers. Let's go ahead and take a break here. It's 9:50. Let's come back about 10 o'clock. Let's take 10.
Hey, Mr. Shoemaker. Yeah. Can you hear me?
Yep.
Yes, sir. Yeah,
I'm on
sorry,
break.
sorry.
I'm
Yeah, sorry
taking
for
a break.
joining in.
I'm taking a break. So,
Okay, gotcha. I'll come back after the break.
okay.
Yes, hello.
Is this Lennon?
This is Lennon speaking.
Good morning. My name's Don McCurry. I'm with the Career Opportunity Center at Carolina Forest.
Yes, sir.
I know you had, was it CDL that you completed?
I did complete the CDL. Yes, sir. Yes,
Oh, good.
yes, sir. But I haven't.
Julie.
Yeah, I haven't had my CDL. I still need to take my CDL test in July. I mean, on the 29th.
Okay. Are you working anywhere now?
I'm going to school at the moment.
That's good. That's good. Sheila, who was here that talked with you, it wasn't here. I was just trying to follow up on parts that we had come through to see where you stood. And, so you're looking to get your heavy equipment operator's license too.
Um,
We want to do that.
is there still a slot available?
I don't know. I don't get on that end. I just have to follow up to see what you're looking for, where you stand right now. But you're still going to school.
Well, I mean, I finished in August 5th, and I heard that the next heavy equipment operator class was around October. Or yeah.
And what you need to do is go ahead and sign up online for that. You know, just like you did. Then you do that. You go online for training and sign up for it so that somebody can call you back.
Okay.
And you have to get line.
Yeah. You're going to do that for me?
I said you have to go online and apply.
Okay. What website do I go to?
It's Palmetto Goodwill.
Okay.
.org.
Palmetto Goodwill.
.org. And there'll be some tabs on top of the screen along the top line. You go to the training part.
Yes.
And click on it, and you go down. You see it'll have HVAC and heavy equipment. Click on that, and you fill out your name and address as a person interested in that course. And it's going to ask you if you're employed or not. And then you put down that you're not your student. And they'll get back with you. The person that calls you back, they call them a career navigator.
Yes, sir.
They stay with you through the whole thing. Whoever calls you back.
Got it. Okay. Yeah,
Okay.
absolutely.
Go online and get lined up for it.
Yes, sir. Yes, sir. Will do. Thank you so much. Appreciate it.
All right. You take care now.
Thank you, sir.
Nay.
Yes, sir.
What's up, buddy?
Oh, no. I was gonna say, I had a little.
Oh, okay. Hold on a second. Oh, sorry about that.
Hey, Professor V, did you ever see my DM?
See your what?
Direct message?
Hang on a minute. I did not, but I'm looking at it right. Come on. Is that old Randall? Wait a minute. I did not yet. I have not, but it will be today.
All right, just asking. I know, we've been out of the class for a minute.
Yeah. We'll get that done today.
All right, Lenny,
Sir.
what's up?
All right. No, I had a little power issues, you know. That's why I didn't sign up right away. The power went out
Okay.
because of the storm. Also, yeah, I was looking at the safety video. And I saw the safety video. I don't know if you want me to share it today or next time in class.
Save it next time.
Sure.
What's your safety video about?
It's just so it's really about you know, what to do when you like if you get into an accident, like when you let's say you crash into a power line, you know, the steps that you should take. I mean, and this is more general. It's not lineman specific, but it's very educational. It talks about difference of potential and you know the shuffle method, you know.
Yeah, that's fine.
And all that.
Okay.
Yeah. Mhm. You know, just basically talk, you know, it basically educates the general public on what to do.
Sounds good.
Yes, sir.
Well, other people listening here, another good one to bring up if they want to do for a safety video is shock absorbing lanyards.
Oh, okay.
All right. You guys everybody got my share screen going on?
Yes, sir.
Yep.
I got it.
All right. This is a short video. It's about 1 minute 40 seconds, but it goes back to pole chunking here in just a short clip. It's really a commercial about line workers in general, but it has a real good section right here that I want you guys to see.
The job is dangerous. I mean, your life's on the line at all times pretty much. And it gives you adrenaline rush. You always got to think ahead. And it's summertime when it's 100 degrees and you off a pole and in a bucket, you got on rubber gloves and sleeves and you're steady thinking, your mind's smoked. I mean, it's just, the heat can hurt you. You have to be fit and have to be in shape.
It takes a special person for the job, the person that.
Okay. This is just a good picture right here, and this is not really the right video, but it's a good picture and indication. You can tell the old pole right in here and the new one and what they've done so far. So they've transferred the two outside phases from the old pole, and now they're getting ready to do the center phase and move it over to the new pole. But that's the situation where you're going to have to chunk this pole out all the way down to the telephone after you strip it out.
Willing to work on the extreme.
And you know, this is a job of watching your clearances and watching your distances. He lifted that phase off that insulator right there. How much distance do you think he has between the phase and the pole? Right in this area right here.
Not very much.
Not bad, maybe 2 or 3 inches. Okay. You've got to, and these guys are trained, well experienced employees right here. First, this guy I know is doing a ton of communications with Jerome here, right here. There's a ton of communications that are going on between the two of them of what they're going to do before they started doing it. You've got 4 hands of control of the conductor going on right here. All right. Another thing to take into consideration here, can't remember the guy's name. He's probably pushing about 170, 175. Jerome weighs right around 260. So we're totaling about 430 pounds, plus the phase conductor's got weight on it, plus all the tools inside their bucket. You guys have got to know the rating of the bucket itself. All right. Don't overstress a bucket. Know the weight limits of the bucket, including all personnel, anything that you've got to lift, plus what's inside of it. I don't know if he gets to the chainsaw part. Hold on.
Condition. It takes a person.
All right, yeah, here we go. All right, so did he wedge cut it? No.
No.
There's no wedge cut. He's just starting a straight cut right here. I kind of like doing it in this fashion. Is he sawing the sawdust towards you, or he's sawing the sawdust away from you?
Away.
Yeah, he's pushing all the sawdust out because he's doing it with the top part of the blade.
That one willing to give a.
Right, there you go. That's typical and perfect right here. You see this section he cut right across here? Then he's got one going up a little bit, the pole just actually rests on itself. Now this gap to me, in my practice, that's a little bit big, but Jerome's a hefty big guy. He's really not taking, I'd say that's maybe, who's eating? He's taking about 3 feet of pole right here, okay? And you watch, he'll lean it over and it'll snap right off. So you got good control right here where he's getting ready to do the cut. I mean, ready to break it off.
100%.
Bang.
I mean, you feel the power.
Okay. And their typical practice, Professor B, correct me if Duke does something different. Our typical practice, especially in that crowded environment, was to get it on the bucket, take the bucket down, drop it off, re-raise the bucket. Now, did you?
Exactly the same way. I mean, unless you were, that bucket was in a tight spot, then, like in the other video, you could run the line truck boom out over the top and, lift it in and out that way as well. But what he said, putting it in the bucket, letting it to the ground, throwing it out was the best way we always used.
Okay.
Depends on your situation.
All right. Any questions there? And you'll notice that was the chunk method. They don't use that full section method anymore whatsoever. Now, can I pull a pole that's in a clear area? Can I pull the entire pole at one time? Is that allowed?
Yeah.
Yeah, that's allowed. Okay. And you're going to have to do the cover up. You're going to have to do everything. It's going to take some time, but you can do a whole pole at one time. As far as cutting one down, we have to chunk it. Okay. Any questions there? I know we spent some time on it, but that is something that you guys will be doing regularly out there in the world, especially on the overhead line crew. Okay. All right, let's jump into where we left off at. And I know it was a long time ago. We talked about 3-phase transformers. Let me get things situated here. Move. There it goes. So, got it. Now, let's see how much you guys remember out here. You should see a whiteboard coming up.
Yep.
Okay. All right, I'm going to draw a couple of different 3-phase configurations as far as banks, transformer banks are concerned. Okay, you guys out there, just pop in and let me know when you know what type of bank it is. What type of bank is this?
I don't see it yet.
You don't see it yet?
Nope.
Oh, that's because it's paused. Why did it pause?
Dang.
You got that?
It's on now.
Okay, good deal. All right, what kind of bank is this, gentlemen?
Electric spring.
What kind of bank type do we have if we have only 2 transformers?
Open delta.
Open delta. We'll get back to wiring configurations here shortly after we've gone through all 3. All right, if I include the 3rd transformer, don't answer yet. And my center transformer has all 3 coming out of the middle. What type of bank is this?
Why?
All 3. 1, 2, 3. All I'm doing,
close delta.
right, all I'm doing here is adding the 3rd transformer. I'm closing the delta. Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. 3. 1, 2, 3. I've got a transformer. It's got 3 bushings, but I only have 2 wires coming out of the center.
Is that a Y?
Y, correct. That center transformer, when you have 3 transformers in a bank, that center transformer is the, I like to call it a primer. It is the indicator of the difference between closed delta and open delta. 2 wires out of the center transformer, Y. 3 wires out of the center transformer, delta. And closed at that if you have all 3 transformers, okay? Now we know by bit, we don't even need to know this or this. If we have 3 transformers, 1, 2, 3, the center one is going to be the indicator. If I have 3 wires, closed delta. If I have 2 wires, Y. You don't even have to worry about the other 2. Okay. Open delta, rarely easy to indicate. How many transformers does it have?
1.
3. No, 2.
2. Open delta only has 2 transformers. There's no such thing as a delta or Y 3-phase bank with 1 transformer. That is single phase, not 3-phase. All right, let's go through the wiring process. We started with open delta. Let me do it in this way so you guys can see a little trick. Clear this. Get this out of the way. Okay, here we go. 1, 2, 3. 1, 2, 3. We'll talk a little bit more between lighting and high leg. Now, Professor V calls, what do you call it instead of high leg?
Power leg.
Power leg. Okay. If you hear power leg or high leg, they're the same thing, one and the same. Okay. 1, 2, 3 bushings on a transformer. 1, 2, 3 bushings on a transformer. All right, I've got neutral, which is grounded. I've got 120 on one leg. Got 120 on the other leg. The wire that goes in between the 2 transformers, anybody remember what that's called? Tie-in bus. That's what that wire is right there between the transformers. Then I've got a wire that comes out of this transformer. This is my high leg or power leg. Same thing, one and the same. Okay, this goes to 7,200. This is grounded. This goes to 7,200. This is grounded. What kind of bank drawing do I have here? Pretty simple. How many transformers do I have?
Open delta.
Open delta. I've only got 2 transformers. The drawings, if you guys still have the printed drawings that we gave you, my drawing's just a little bit different from those drawings. What's the difference?
Well, it shows well, it's got all the lines, the 3-phase lines and the neutral lines.
What's the difference between my wiring on the secondary and the wiring on the secondary that you have in your drawings?
I'm sorry.
What's your question again?
My wiring, and it pay close attention to this area right in here. I'm going to circle it. What's the difference between my wiring right there where I circled and the wiring that you have in the drawing for open delta?
Yours is going down.
Where at? Right here?
Yeah.
Man, right. They have theirs attached right here and going down. It's the same thing, guys.
Oh, okay. I
It's
see.
the same
Yeah, I
thing.
understand what you're talking
Okay.
about.
There's no difference in the two. Hold on one second. My goodness. Scott Schumacher. Good. Yeah, we are. All right. All right. All right. Okay. All right. Sorry about that, John. All right. So we have an open delta bank here as far as this photograph is concerned. I mean, the drawing is concerned. An easy way to go ahead and let's see that. I want to get rid all the way down. Okay. I'm going to draw this line back in. As far as a closed delta bank, what do I need to add as far as how many transformers do I need?
3.
So I need another transformer. 1, 2, 3, 1, 2, 3. And draw it down like this. All right. I'm going to have a tie-in bus between the two. This direction now, I've added my third. Both this wire and this wire interconnect and make one conductor. Suddenly, I have just created a closed delta bank. Now, what do I need to do with the neutral ground for the primary on a closed delta bank? Do I attach it to ground or do I float it?
Float it.
Float it, right. It does not connect to the neutral up top. It is a floating neutral. So real quick, all I had to do. All I had to do here was add the extra transformer on this left-hand side, tie these two conductors together on the outside of each transformer. Now I've got 1, 2, there's my third phase down here at the bottom, and neutral. I made a closed delta bank just by adding a transformer. Now you can really, if you want to, as far as your drawings are concerned, you can take a closed delta bank and just flip it the other direction and take one transformer away. As soon as you take the left-hand transformer away on a closed delta bank, you've now got a what? Open delta bank. See, you just created that real quick and real easy. The thing that it's different, this is the only bank. Closed delta is the only bank that has a floating neutral. All others are tied into ground. Any questions so far? Nothing hurt. Can you hear me, V?
Yep.
Okay. Let's clear this drawing right here. So that takes care of open delta and closed delta.
Yep.
And what's the third one we need to work with?
Y.
Y.
How many transformers are in a Y bank?
3.
Okay, 1, 2, 3. Here's my first. My second. And my third transformers. 1, 2, 3. 1, 2, 3. 1, 2, 3. 3. I'll go ahead and do just like the normal transformers we have out there in the world. Now, Y is a little bit different. 7200, 7200, 7200. And you'll notice on all three transformers, which primary bushing do I use, left or right?
Left.
Left. You need to use either all left or all right. Okay, it doesn't matter left or right, but all three need to be the same. Okay, what do I on a Y bank? What do I do with my neutral bushing?
Ground it.
Round it. Perfect. So I come up here and then I go to ground. All right, in Y transformers or Y back transformers, what do I need to do to each individual transformer first inside the tank? Do I need to convert these transformers to one single voltage?
I believe so.
Okay, you believe so. How do you do that? All right, I'm going to draw the bushings of the transformer on the outside. And this is in previous videos, guys, too. So if you want to go to previous videos, you can see this also. This will be on the YouTube today. Inside the tank, they have a lead. And that lead is A that attaches to that bushing. Inside the tank, under this bushing, is B, C leads that feed it. And under this bushing is D. Maybe this is starting to trigger some of those. Oh, yeah, I remember that. All right. In this configuration, I'm going to get 120 neutral, which is grounded, and I'm going to get 120, and combined together, I'm going to get 240 volts. That's how they come from the factory. Okay. I need to convert this transformer to be all 120 only. What do I need to do with the leads?
Connect one lead from the 120 to the neutral.
Stand by. Fixing my drawing here. Hold on. All I'm worried about right here is lettering. Where do I need to move these leads to make this transformer all one voltage?
A to B.
Okay, I'll make it simple on you guys. What kind of electricity do we use in the industry? AC or DC?
AC.
AC.
All right, I'm going to make this AC. This one away. What's left?
Okay, I see.
What's left?
DC.
No, AC's over here.
Okay.
What's
What is-
left?
You said what's left?
I'm using AC over here. I've moved my C from there to here. What's left?
B. So you use BD over there.
There you go. BD
Okay.
on this bushing. All right. Now, and this is in your brain processes when you're out there in the world. This is the easy conversion process. All transformers have these letters inside of them. Single phase transformers. If you want to convert it to one single voltage, make one bushing AC, you're moving leads, and make one bushing BD. All right. I'll show you in the wiring process here. Hold on one second. Control Z. You remember this from a quiz question you had before. I've got a primary winding and I've got a secondary winding. And there's two of them. This goes to neutral. This is 120. This is 120. Who can remember how I get 240 out of this transformer? What's happening with these windings?
Going in opposite directions.
There you go. Perfect. That's good recollection and good remembrance right there. When I change it to ACBD inside the transformer, guess what the windings do?
Flow in the same pattern.
All one direction. That's all you're doing when you're doing that wiring process. You taking my picture? Isn't that sweet? Okay. When you move AC and BD and join those together under a bushing, you're making all of this one direction, which in turn, I can only get one voltage out of the transformer. Okay, so let's get rid of all this. So you'll see on the top of those papers that we gave you, you're going to have an open delta bank, a closed delta bank, and a Y bank. Every single one of those questions asks, do the windings need to be changed? On open delta, do the windings need to be changed?
No.
No. Closed delta,
No.
why?
Because they don't have to flow in the same direction. They
Right.
flow opposite and connect.
So that's a simple straight up answer. Yes, they need to be changed. AC, BD. That's all you need to put there. Okay. So let's get rid of this. Now you will see some different transformer makeups. And Professor V, stop me if you've seen some different configurations here. We all buy the same transformer for the entire company at Santee Cooper. Okay. We have to convert all of our transformers. Some companies buy transformers that are ready-made this way, but I'd like to do it this way in case you run into the more difficult situation. Okay. So what I'm going to do here is I've got to have one neutral wire and 3 hot wires. I'm just going to go from here. Typically, we go from left to right. So I'm going to go down here, neutral. That's neutral also. And that's neutral also. What do I call this wire when I go in between transformers?
Tie-in bus.
Excellent, excellent. So now I've got my neutral on all 3 transformers. It's interconnected with the tie-in bus. Remember, I'm only going to get 1 voltage out of each transformer. 120, 120, and 120. All right. And remember, I know it's going to be small. On all my transformers, I went AC, BD, AC, BD, and AC, BD. Okay. So now I've got 120, 120, 120. So I've got my neutral and I've got my 3 hot that I've satisfied that. Careful. Be careful here. I'm going to ask a question. I'm using A, B, C phases for my primary. That's 3 separate phases. What is my voltage combined between here, and between here? Careful. 3 different primary phases. 120 from here to here is going to be what combined?
240.
Careful. Am I using a different primary phase? Up top.
Yes.
Can I have in my AC sine waves, can 2 different phases be the same peak voltage at the same time?
No.
No. Remember what's happening at the top. Golly, why is it doing that? What's happening at the top also happens at the bottom. So we're going to use the same conversion process we use for primary. When I have 2 different separate phases of primary, what do I multiply it by? Remember the magic number?
1.725.
1.7325.
Right. So I'll do the primary side. That's going to come out to 12,470. What's happening on top also happens at the bottom. So what do I need to do? 120 times what?
The magic number.
There you go. 1.7325. What does that give me? Should be 207.9. Everybody agree?
Agreed. 207.9.
Okay. We rounded to 208. There you go. So now you have converted the bottom voltages and you know what they are. Question, gentlemen. Is there a high leg in this 3-phase bank or a power leg?
Yes.
Put your thinking caps on here, and what I'm looking for is there a power leg in this bank? Go by individual transformer. What's the voltage here? 120. What's the voltage here? 120. And what's the voltage here? 120. Is any of those giving an indication of a power leg?
No.
No. There's no power leg in a Y bank. Only delta has a power or high leg. Professor V, anything you'd like to add there?
Just remember, guys, the tie-in bus on a Y bank is not energized. That is for the neutral, and which is reverse on the delta bank, where they're actually connected through the hot terminals on the transformers.
Right, right. Okay.
So
But what time are we holding here? What is this?
10:30.
30.
Yep.
Okay. So let's go ahead right here and take 10 because my phone is blowing up. Let's actually take about, let's take 10:45. Take a break here and come back so I can answer my boss.
Yeah.
Okay, so a while back, Professor V, are you back? Hold on one second. Prior to our drone training week, we gave you guys transformer drawings and multiple copies of the blank sheets for drawing the transformers in. Does everybody still have the blank drawings? Or do we need to print some more?
I have to check. Let me
Okay.
let me go see.
I got them. I just need a diagram of the open delta and a delta transformer.
Okay, that's an
Hey,
ELW.
Lenny, I'll send you a picture of it if you want it.
Yeah, well, it's in ELW 112.
Roger.
All those
Okay.
drawings are in there. Yeah. If you go to ELW 112 and that course landing page, all the drawings and actually the blanks are in there too, but we will print out more blanks because we're going to need them tomorrow. Okay. So your blank sheet should look something similar to this that you see on the share screen. Do you have the share screen up? Is it showing?
Yeah.
Okay. All right. What I'm going to do here is just go through each individual one that you're going to be drawing tomorrow on the blank sheet. What we're going to do tomorrow is do these 3 transformer banks in a drawing on the field. You're going to hand it in to me and Professor V. We're going to grade those and then commence to do climbing. Now you can, if you want to climb and then do these, we just need them by noon tomorrow.
Yeah.
Out there in the field. So the first one I'm going to start with, and you will see different voltages. Professor V, do you have them in front of you?
Uh-huh.
You do? Okay.
Yeah.
Give me, because I've limited my space on room for drawing here, so it
Are
should.
you starting with the open bank?
If you want to, that's fine. What's the voltages for open delta?
Open delta?
Yeah.
Okay, open delta. You're looking at 7,200, 12,470, 240, 480.
Thank you very much. Yeah, that's my primary voltage. Secondary voltage is 277.
240, 480.
240, 480. Thank you. Dang it. 480. Okay. So he's said this is going to be open delta. Guys, I would highly encourage, especially I'm doing it in this fashion right here. This video is going to be out today. As you study this video, and you'll be like gold here. Okay. So he said open delta here. My first indication, how many transformers do I need?
2.
2. Okay, so I'm going to go draw in 2 transformers. 1, 2. All right, that starts me off. Now you're gonna have to put, you'll notice on the primary side and on the secondary side, there's no voltages that are included. You're gonna have to draw those in. So my first number here, my 7200, is my phase to ground voltage. So I'm gonna go from A to N, B to N, C to N, and this, the number's already provided for you, 7200, 7200, 7200. That satisfies my phase to ground voltage. Now I like to make myself a little room here. It's also asking you to draw in the phase to phase voltage. So I'm going to go from A phase to B phase, B phase to C phase, and A phase to C phase. That captures all 3 phases combined. And what's that voltage? 1, 2, 4, 7, 0. 1, 2, 4, 7, 0. And from A to C, 1, 2, 4, 7, 0. Okay. So my drawing part as far as voltage is concerned on the primary side, I am finished right there. Now on open delta, I have to use 2 separate primary phases. If you want to go by your drawings, that's more than satisfactory. All right, I'm going to use in mine, I'm going to go to A phase, connect. Remember, if I use the left-hand bushing on the transformers, I need to use the same on every transformer. And I'm going to go to B phase. That satisfies my primary connection. What do I do with the neutral bushing, the grounded bushing on open delta? Do I float it or do I connect it to the neutral?
Connected to neutral.
Right, so I'm going to make a connection right here. Both are interconnected right here, and I took it to the neutral. In fact, if this helps out a little bit, my neutral's grounded. Okay. Now I've taken care of, satisfied the primary connections on the top of the transformer. Let's go ahead and draw in our bushings. And this time I'll draw it as per the drawing. We know in delta, remember, this is the lighting transformer, and this is the high leg transformer. On the lighting transformer, we have the center bushing. It goes to where? Neutral, and this neutral is grounded. Bang, bang, bang. This is 240, 480. I haven't drawn them in yet, but I can go ahead and draw my lines in. Make this kind of simple for myself. I'm going to go A. I'm going to go B. And where's the third one go? C. So I've got interconnection between A, B, and C from all 3 transformers. What am I missing in between?
The bus bar.
Tie-in bus.
Or tie-in bus.
I got to satisfy my tie-in bus in between the 2 different transformers. Guys, you just wired the secondary. Real quick and easy. A, B, C, and I've connected to the neutral. The only thing that's left now is voltages. Okay. So from A, it's just like the primary, A to neutral, B to neutral, C to neutral. You got to be careful here. This is a high leg. Remember, this transformer is a high leg. From A to neutral, what's my voltage? 240. From B to neutral, what's my voltage? 240. Here's the thing that you need to look out for in the delta configurations where you have a high leg transformer. What is C to neutral? It's the high leg. What do I need to do here with that 240 number?
Multiply it times 1.7325.
Excellent. Excellent. That's because now I'm using the primary A into this transformer and another primary B into this transformer. Remember, I cannot peak on 2 primary voltages at the same time. That's going to affect the secondary also. What is that number? Should be about 416.
Mm-hmm.
Okay. Is that right?
Yep.
So my C to neutral is 416 volts. Phase to phase, A to B, B to C, A to C. You notice I did it just like I did my primary lines. Trying to keep things kind of in order here. Real simple on this one, 480, 480, and A to C. Sorry about that. Double line there, 480. Am I finished?
No.
What am I missing?
You gotta multiply. Oh wait, yeah, no, you're finished.
Yeah, we got that. We got that. Okay, that's the only time we need to multiply by 1.7325 is in a delta high leg. Delta high leg, the phase to ground voltage gets multiplied by 1.7325, and that is 416. We satisfied that down there. I'm finished.
Yep.
Okay, that's all there is I need to do there. Things that, you know, I need to really keep my eyes on. I need to ground the bushing on the transformer on the top. That needs to be grounded. It's not floating. And don't forget your tie-in bus. Okay, any questions there? Hearing none. Because I did open delta first, you know, it's kind of in my brain now. I'm just going to go straight to closed delta. So let me clear this screen. Get my lines drawn in. Should have left myself a little room there, but I didn't. Okay, that's my primary lines. Professor V.
All right.
All right, I'm going to close delta. What are my voltages?
19.934.5.
19.9 kV to 34.5 kV. And my secondary voltages?
120, 240.
120, 240. Thank you. Okay. So what's closed delta? How many transformers do I need?
3.
Very great. So I'm going to draw them in. I'm going to keep the same order here that I did before. What's my phase to ground voltage? 19.9 kV. A to N, B to N, C to N. Neutral is grounded here at the end. 19.9 kV, 19.9 kV, and 19.9 kV. You see a pattern that's going to be going on here between the last one. My phase to phase voltage is 34.5 kV. A to B, B to C, A to C. Sorry, I almost did it. 34.5 kV, 34.5 kV, and 34.5 kV. All right, we've got 3 transformers, so we're going to be using all 3 phases. I'm going to make it easy on myself. A, B, C. Okay. A, B, C, left to right. Got my neutral bushing. Connected to that neutral bushing. Connected to that neutral bushing. Do I need to connect it to neutral that is grounded?
No.
No, no. This is the only bank that you do not do a connection at this point. I'm going to call that my floating neutral. Okay. Go ahead and draw my secondary bushings here. All right, and I got to remember this one correctly. It's a little bit different in the drawing than actually what you do out in the world, but I want you guys to be able to study your drawings and be able to go on that. Center transformer is my lighting transformer. The two outside transformers are now high leg. Center one of this transformer, it's the same thing. When I say lighting, it's the same thing that can power your house. Neutral. This is going to go down to B, connect. This is going to go down to C, connect. All right. What do I need to do in between transformers? What am I missing between here and here? Tie-in butts, both directions. Now I have 3 transformers total. Tie-in butts both directions. My high leg is now going to come out here to A, and this high leg also comes to A. That makes it 1 conductor. So I've satisfied 1 neutral and 3 hot legs. Okay. Remember now, A is the high leg. Okay. This is where some people get tripped up a little bit. Secondary voltages. A to N, B to N, C to N. A is my high leg. Okay, that beginning voltage is 120. What do I need to do to that because it's my high leg?
Multiply it by 1.7225.
Yeah, excellent, excellent. Which is 208. All right, the rest of them are phase to ground. 120, 120. All right, phase to phase. 240 on my secondary side. Very simple. A to B, B to C, A to C. Two 40, 240, 240. Am I finished? Anybody
Yes.
see any errors there?
No, you finished.
Okay, good to go. The thing is on the closed delta, and I'm going by the picture that we had before, A is now my high leg. You got to know which ones are your high leg transformers, and that's what I'm connected to. On open delta, it was C. Closed delta, it's A. Watch out for that when you're doing this calculation, 120 times 1.7325, or whatever the phase to ground voltage is, to get your high leg voltage. A lot of people trip up on that. Do the windings need to be changed in these transformers? What's the only bank that I need to do winding changes on?
The Y.
The Y. So windings do not need to be changed in these transformers. Professor V, anything that you could, special notes here that you would tell students as far as things to look out for? I know I got the high leg part.
Right.
Another one here is the floating neutral.
Floating neutral, that's
This
correct.
is, the only bank. This is the only bank that has a floating neutral.
Yep.
Professor, when you say change the windings, do you mean like change out a different transformer or like actually change the physical windings in the transformer?
All right. I think this video has been up enough. I'll show you here. Let me clear this one off. Okay. So a transformer by itself, I'm going to draw it here. 2, 3, 1, 2, 3, 1, 2, 3. A transformer by itself, when it sits here, is in this configuration. I'm going to actually draw the winding configuration. Here's my primary winding. You see how these wires are coming off?
Yeah.
That's actually how it's coming out of the bushings of the transformer. All right, this is how it comes from the factory. These are in opposing directions. So I should get 120, 240 out of the transformer inside the tank of the transformer. And if you want to, I mean, we'll get some time tomorrow, or when we come back next week, we'll bust one open and let you see the actual leads that come off the transformer. There's a lead in there, and it's got stamped on it A, and that's 2 under this bushing. They're both stamped BC, and there's only 1 under that bushing is stamped with a letter on it D. This is how it comes from the factory. In order for me to get 1 single voltage out of a transformer so I can use it in a Y bank, one, two, three. I've got to change the direction. Those 2 windings that were going different directions, I got to change them all to go in one direction. And they make it simple by the lettering. I've got to change I'm going to do the actual here, A, B, C, D to A, C. I'm going to move my C winding over to the A bushing, and I'm going to move my B lead over to the D bushing. So this is going to now be BD. In reality, I took this, which I started off with, 2 different directions, and I changed it to this. 1 direction when I move those leads around. This bushing is not used at all. Is that the answer that you're looking for, or a question you're asking?
Yeah.
Okay.
Yep.
I mean,
yeah, because the way it sounded like we would physically open the top and like change the inner coil or whatever.
you're not changing the inner. Well, you're changing the configuration of the inner coils. Yes, you are opening the actual tank of the transformer, but when you move those leads to AC and BD,
gotcha.
Your result is that.
So how does that work if there's those 3 lines and because on the BC there's only one line coming out of BC. So how do you connect it twice?
It's folded.
In which, yes, folded.
Oh, okay.
In a drawing, yeah, it's easy to do it like this. Let me see if I can do it. It's kind of hard to draw. It goes like this. No, that's wrong. I got it wrong already. This, there it is. It's folded like that. Okay. Does that answer your question? Because I was going more on wires, but what you were asking.
Yeah.
All
yeah,
right.
I understand it now.
Okay. All right. Yeah. On a configured transformer for a single voltage only. Let me clear all this off.
Meet Melio, a free online payment solution.
Okay. Sorry. Go ahead.
On the wiring on the outside of the transformer, remember we got to have neutral ground to have a complete path. Neutral, nothing in this one. 120. Okay, that's what it looks like on the outside. You only have 2 wires coming out of the transformer instead of 3. And everything's going one direction. This bushing is now empty. You move C over to here and you move B over to here. This bushing's empty. But here's my new neutral. Does that help?
Yeah.
Okay, good. All right, so let's clear this off and we'll go to the last one. All right, A, B, C, N, A, C. Limited myself for space there. N, 1, 2, 3.
It's for Y, right?
Yes, sir.
Mm-hmm.
N, 1, 2, 3, and grounded. Grounded. Professor V, voltages, please.
Primary voltage is 4160, 2400.
2400.
2400, 4160.
Understood. Why did it do that? There we go. 2400.
Yep.
4160.
Yep.
And secondary?
277, 480.
277480. Okay. How many transformers do I need in a Y bank?
3.
Excellent. That's a fat transformer. Okay. My voltages, I've got 2400, 4160, same fashion that I did it before. A to N, B to N, C to N, 2400. V, V, V. Phase to phase voltage, 4160, A to B, B to C, A to C, 4160V, 4160V, and 4160V. Okay. I'm using 3 transformers, so same as before. I like it this way. A, B, C. I'm going to work on my grounded neutral bushing. 1, 2. Connect here, come over to here. I remembered from before, hey, closed delta is the only bank that floats. So, bam, I need to connect this one. Closed delta is the only bank that has a floating neutral.
So you're grounding this one, right? Correct, right?
There you ground this one, correct. Okay. Draw my secondary bushings in. 2, 3. 1, 2, 3. 1, 2, 3. Now I'll ask the question now, because you guys have heard it multiple times. Do I need to change the windings in the transformer?
Yes.
Yes. Okay. Remember on the other 2, it's no. Yes. A, C, B, D. And you're going to see some different configurations out there in the field as far as which bushings they use. I like separation. It just looks a lot cleaner to me. So I'm going to say the left-hand bushing on all of my transformers that I have converted to AC BD is going to be my neutral bushing. So left to left to left to neutral. That's my neutral. What's left? Remember, I've only got three legs and bushings to use. Real easy here, guys. A, B, C. So my left-hand bushing is neutral on all 3 transformers. Bang, bang, bang. My right-hand bushing is where my BD is at, is my hot wire. A, B, C. Wiring's done. And all I have to do is go with voltages. 277 is my phase to ground voltage. Now, be careful before you answer this. I asked this question before. A to N, B to N, C to N. I think Jordan is one that answered it. Is there a high leg in Y? That question was asked just no more than 30 minutes ago. Is there a high leg in Y? All right, let me bounce back here. My phase to ground voltage out of is going to be 277. What am I going to get out of this transformer? 277. I've only got 2 wires. What am I going to get out of this transformer? 277. I've only got 2 wires. What am I going to get out of this transformer? 277. I've only got 2 wires. Is any one of those 3 transformers a high leg?
No, no hollow.
No, it doesn't have one. Y does not have a high leg. So I can put my voltages in here, 277, 277, 277. Big thing to remember, no high leg. Oops, well, in Y. You don't have to calculate it. 1, 2, 3. I phase the ground voltage, 480. A, B, B to C, A to C. You see, I keep the same pattern. Just keeps my mind right. 480 B, 480 B, and 480 B. What you think? Professor B?
Pretty easy stuff.
Yeah. Well, pretty easy stuff for guys that have been doing it for how many years?
Yeah, a long time, 30 years.
30 years. Okay, so tomorrow you're going to get 3 empty sheets. Luckily, he took them right off the sheets. They're going to be the same voltages as you got today.
Yep.
I would highly recommend that you that you review this video multiple times, look over it. Tomorrow you will get these same sheets. They will be blank. You will have to fill in this information. All right, obviously, who's going to be out there tomorrow to help you out?
Professor Shoemaker and Professor Vermine.
Right, right. We don't give answers, but we will lead you in the right direction of where you need to be.
Mm-hmm.
All right. And some things you think are very simple. Well, how many transformers do I need in an open delta bank? They'll tell you. Okay.
What's the application for all these transformer banks?
Good one. That comes up in a later test, but this is a good one. I just want the drawings done tomorrow. Clear all drawings. Okay, so what's the application? Fantastic question. So what are the 3 types? I've got Y. I've got open delta. And I've got closed delta. Closed delta. Okay. Let's start off even prior to that. Why do I need 3-phase at all?
Because 1 phase is just not reliable.
Right. I get better power quality.
Oh yeah, that's what I mean.
Right. It's able to turn motors a lot better, and I don't have any power drop off. When I've got 3-phase, it doesn't go to the 0 line 3 times per cycle, right? So that's the general good benefit of using 3-phase. The different types of 3-phase, and I'll give you some examples here too. Y is a balance of, and I'll do the phase symbol, single phase and 3-phase loads. So inside my business, I pretty much have as far as my load needs, I've got some single phase that I need to power, and I've got some 3-phase I need to power, and it's pretty close to 50-50. You will see the college is Y. It's got a lot of lights, and it's got some 3-phase motor load for air conditioners. It's pretty balanced. It uses Y. A lot of your restaurants, Taco Bell, Burger King, all those kind of places, they use Y. I would probably be safe to say, Professor Roman would probably jump in on this too, Y is dominant.
Yeah.
Y is the most you're going to see out there in the world as far as 3-phase that's being used by customers. Open delta is high, single phase, small, 3-phase loads. All right, does anybody know where Oliver's is up there in Red Hill, that burger place?
Yeah.
Okay. You get a chance, drive by there, look around on the poles. It's got an open delta bank that feeds Oliver's. All right. He's got a good bit of single phase lighting. He uses gas grills, but most of it's, lighting inside the place. He only has one 3-phase load in that place, and that's the AC unit.
Oh, really?
That's all he has. Now that AC unit in the summertime pumps it down about 68 degrees. He's killing it to keep it cold in there. But that's the only 3-phase loads he has. So I don't need closed delta. Open delta, I only need a little bit to get that third phase for the AC. I don't need closed delta. It's just as simple as that. The 3-phase load that's in there is not that high. So I'm not going to spend a lot of money and put 3 transformers in. All I need is 2, open delta. All right, closed delta, which is really kind of phasing out because of Y. Y is starting to take over the planet here. Closed delta is, probably a medium single phase load, but a very high 3-phase load. Who knows where Canfor is at? Canfor out there in Red Hill, the lumber mill.
Oh, yeah.
Okay, great example. They've got some offices, they got some stuff that's got, a little bit of medium load, but what are they using predominantly out there in the plant?
Saws and stuff.
Saws, motors, fans, whatnot, very high 3-phase load. So they need that additional 3rd transformer to be able to power that 3-phase load. Does that kind of give you a good indication there?
Yeah.
All right. There's also one benefit here of closed delta, and we talked about this a good while back. Let me get this cleared off. All right. We talked about this a good while back when we were at the generating station and the step-up transformer. Transmission lines. I've got 3 conductors on transmission lines. We can tell this right away. Is that open delta, closed delta, or Y? What am I missing? On the tops of the transformer for primary and closed delta, what do I have? A neutral? Do I connect it to the neutral?
Yeah.
Closed delta.
No, floating.
No, it's a floating neutral.
Floating.
It's a floating neutral. So transmission is predominantly delta. I've got 3 wires. It's closed. There's a hidden benefit that goes on in here, and I'll draw the transformers for themselves in transmission and closed delta. I'm going to do it from the transformer side now. I'm just going to draw the primary side. Okay. Let's talk a little bit about loads here. Say I've got on this transformer 200 amps that are being drawn. And on this one, 160. And on this one, 209. That's just by the connection that's going on inside the place of business. Remember, I'm floating the neutral. When I have my neutral connected in the regular world, are these balanced for starters? 200 amps and 209, they're not balanced, okay? All right, where does unbalanced load go when I do have a neutral? When it's imbalanced, where does it go? When I do have a neutral.
Goes back up the neutral.
Goes back up the neutral. Well, I don't have a neutral in closed delta. Where does unbalanced flows go? And when I have a floating neutral, where does unbalanced go now when I don't have a neutral to use? What's interconnected?
The floating neutral.
Right. It's interconnected to what? All 3 transformers. This is what we call load sharing.
Oh, so okay.
Okay. Closed delta is very good at load sharing. So when I get up to 209 on this one, it's going to go where? I think I'll give a little bit to here, and I think I'll give a little bit to here, and this 200 amps, you know, and the sine wave is sharing that load between all three transformers until you eventually see it, you know, pan out. 201, 200, 200. And that's just, you know, extends the life and makes you be able to use those transformers for much longer and get more efficiency out of them. Same things happens in transmission. I don't want 900 amps on this phase, 600 on this one, and 700 on this one. What do I want? 800, 800, you know, 800. I want it to be completely balanced so I get more efficiency out of my system. That's the benefit of closed delta. Okay. Now, anything that I've got connected to a neutral, which is why open delta doesn't have that. When we start getting into the electrical power systems, you'll see the difference. Okay. Any questions of what we've gone over today? So what's the plan for this afternoon? What you going to do this afternoon?
Study these drawings.
Watch these videos.
Yeah. Now, we want it done in front of us tomorrow. So don't, I mean, if you want to practice on your blank sheets, by all means, you know, study this, look at your sheets, watch the video multiple times. I'll actually go into the video and start the time of which I did the last 3 drawings. So you can, you know, fast forward to that time and watch that over and over again, and be prepared tomorrow between 8 and 12 to supply me all 3 drawings drawn out. Now, what was it, Professor V? We had, there's like 90 different, I think it was 96 different points that you can mess something up on.
Right.
So they're worth 1 a piece, but you know, get the best you can out of this thing.
Yeah.
And making the wrong connection in one spot could screw up about 5 more. So make sure you got all your connections right. Take your time. Any questions from anybody today before we get ready to close it up? Stop share. A reminder, tomorrow is the last day of practice. Next week is test week for overhead.
Yeah.
So there